you say?
Well, I was just going to ask you when you decided the test would be next week.
The test is probably going to be next week. I'm looking at the end of the week, so more than likely we'll probably do the test, the written test Wednesday, the computer test Thursday. That'll give me the weekend to do the computer test. Okay, so that's probably what we're going to do. I may do it a little sooner because I don't want to kill you guys, but if I'm going to kill you, it's better early than later. Okay? Yes?
And do you know what material it's going to be over?
It'll be the rest of 3, probably all of 4, and more than likely some of 5. Kind of depends, but probably. Okay? All right. So let's talk about 4.1 today. 4.1 deals with scatter plots and correlation. Correlation. Okay? So a scatter plot is a graph that shows the relationship between 2 variables. Okay? And we try to put the explanatory variable on the x-axis. Okay? Now, that's not a hard and fast rule. A lot of times it's kind of hard to determine which one's the explanatory, which one's the response. But if it makes sense, you'll try to put the explanatory variable on the x-axis. So this is kind of a first step in analysis. You should do more sophisticated analysis later, such as regression. I think we're going to talk about regression tomorrow. And the idea is we're going to look for a straight line pattern, and I'll write it over here. If we see linear pattern, then calculate the the correlation coefficient. Okay, I'm going to go ahead and I'm going to give you that equation now. The correlation coefficient is the letter R, and it's 1 over n minus 1 times the sum of xi minus x bar over s sub x times yi minus y bar over s sub y. Okay? So that's the formula for the correlation coefficient. But remember, you shouldn't do that until you've at least looked at a scatter plot first. Okay? Now, some notes about the correlation coefficient. It's always between -1 and +1. It tells the strength of the relationship between 2 variables. Okay, and so if I said that the absolute value was greater than 0.7, absolute value, we're going to call that strong. Now I'm going to give you these rules today, and then tomorrow I'm probably going to break them. But we'll use these for now. Then 0.3 to 0.7, absolute value. That's going to be moderate. And if it's less than 0.3, that we're going to call that weak. And I'm talking about the absolute value. Okay? All right. That looks a little bit better. All right. So let's look here. I want to show you a couple things about, we're going to go to, oh, actually, let's start here, especially since I already have that open. So the idea here, let me start sharing. The idea here is correlation kind of tells you how close the dots are together, okay? So you can see that, so this would indicate stronger correlation. This over here would indicate, because the dots are more spread apart, weaker correlation, okay? So that's the idea that we're doing with correlation coefficients. So for example, now a lot of times zero correlation will indicate no correlation, but not always. And I'll give you some examples of that in just a minute. But this is an example. You can see that there's no real pattern going on here. If I were to draw, here we go. If I were to draw a plot here, okay. So this one here, we would call a null plot, okay. It kind of looks like a hamburger. Hamburger, okay. So if you see something like that, that indicates that there's probably no correlation between the two variables, okay? So for example, if I were to say compare your age with your test score, do you think that would be highly correlated or weakly or no correlated? Maybe weakly correlated, but probably very little correlation. So you would expect that would look kind of like this hamburger pattern. There's no real pattern here. Now, as we get here, you can kind of see this would be an example of weak correlation. You can see that there's kind of an upward trend here. That would be an example of 0.28, very weak correlation. As we keep going here, this will be stronger correlation. The dots are a little bit closer together. Now they're even more closely. This one you can kind of see pretty well. Correlation coefficient is 0.72. In this case, really super well. That would be a correlation of 0.89. This one, I'd almost wonder if my data was faked. It's so strong, okay? Very strong correlation. So we're looking for a straight line pattern. So the patterns that we're looking for, basically we talked about this, the null plot. We also could have something that looks like this, okay? So that would indicate a nice straight line. It may look like a hot dog. Or you may see something that looks like, what does that look like? What food item? A banana, right? Okay. So this would be a banana, okay? If you see a pattern that looks like this, that's going to indicate non-linear correlation. So our correlation coefficient only works if your pattern is linear, okay? If you see a banana, probably shouldn't use this equation. So remember, your scatter plot is your first point of analysis. You're looking for, something at least maybe like that, okay? Kind of a hot dog pattern. It looks like roughly a straight line. No pattern, or you don't want to see a lot of curves in it, okay? Now, another website that's really good is actually Wikipedia. And if I pull this up here, okay, they've got a nice thing here. Okay, as we look at this, now you also want to look and see if it's positive or negatively correlated. Oh, I didn't write that on the board anyway. Look for positive or negative correlation. Okay, so these are some other examples of correlation. So you can see this is +1, this is -1. We would say that those are equally strongly correlated. Okay, so the Sine, well, and in fact, if you look at this second row here, these are all positively correlated. These three are all negatively correlated, okay? So it's not really the slope, other than you can say that these are all positively sloped, these are all negatively sloped, okay? So correlation isn't slope per se, it just tells you how strongly related they are. So you've got really strong here. This one is still pretty strong. This one's more weak, maybe moderate. This would be an example of no correlation, okay? Now the problem is, if you use this equation over here to find R, your correlation coefficient, if you didn't look at your scatter plot, this third row here, this represents a correlation coefficient of 0, but these do not indicate that there's no correlation. For example, this is really curvy here. This would indicate a non-linear correlation. These two look like fake data to me, but once again, I guess you could kind of call those a null plot. It seems kind of strange. This would be something you would see, kind of a quadratic plot here, kind of a parabola. This looks like two parabolas here, I'd say. I've never seen anything like that in nature, but you know, it could happen, I guess. This looks like a petri dish. I don't know. That's kind of weird. This looks to me like I've got 4 different populations here. So the idea here is, whenever you're doing correlation, you should always do a scatter plot first, because you want to make sure, especially in this case, if it's no plot, or well, we don't have any bananas up here, but you could see a banana of some sort. Okay, does that make sense? If you see a banana, kind of a curvy thing, or if you see a quadratic thing like this one here, you're probably gonna say, oh, I don't want to use this equation because this equation assumes it's a straight line pattern. Yes?
So can we only use the equation for positive?
No, you can use it for negative as well. Yeah, it works just fine for negative. It doesn't work well for curves though. Okay? All right, so let's do an example here. If we go to assignments, and then I've got worksheet 4.1. Go ahead and open that up. In class worksheets 4.1. All right, so we've got some data collected here. And so a golfer is chosen to swing a ball on a 70-degree day with no wind. You want to see if there's a relationship between the club head speed and the distance in yards. So one of the other things that I want to point out here, notice club's head speed, this is in miles per hour. Your distance is in yards. So correlation is actually a unitless. It has no units. You can compare two things that have nothing to do with each other. Speed, miles per hour, yards, those are completely different units, okay? So correlation coefficient is unitless, okay? All right, so now, as we look at this, for some of you, I'm gonna give you some steps to calculate, okay? Let's look closely at our formula. I will give you this formula for the test, okay? I won't make you do this for the quiz tomorrow. It'll take too long. But what does X bar and Y bar represent? What'd you say? The mean? Which mean? Okay, it's your, so you need to find your sample mean for X and Y. What do you think S sub X and S sub Y stands for? The standard deviation, I think I heard that. Okay, I know I got headphones on, but so find the standard deviation for X and Y. Now let's look at this piece here in the parentheses. That looks a lot like another formula that you've learned recently. What does it look like? Well, S is the standard deviation, but what does the parentheses look like? It looks like a Z-score, and that's exactly what it is. Find your standard scores for your X and your Y, okay? What are we doing with our standard scores? We're going to find the product. Okay, what does this mean? Find the sum, add them up. Add them up. Okay, and finally, I've got this as a multiply, but you could also write it as a divide by n minus 1. Okay, so like I said, I will give you this equation. So you don't need to memorize that. I will not give you the steps. Okay, I'm going to assume that if I give you the equation, you can find these steps. If you want to memorize those steps, you can. But I'm going to give you this. Okay? Yes?
So what did you say was unitless earlier?
R is unitless. Okay? All right, so we're going to go through this step. So, yes. Find the standard scores. Okay? All right, so now, let's pick on Marin, because I remember your name. Marin, what is the first step I'm supposed to do? Find the sample mean of X and Y, and how do I do that? And so I could add them up and divide by the number, or I can use what other command? Mean? No, unfortunately, the mean doesn't work. We got to curse Bill Gates when we do this because he didn't use the right word. What's the right word? Average. And so when you do that, just curse Bill Gates. Okay? The mean, so the mean is 101 miles per, almost 102 miles per hour. The mean distance is almost 267 yards. Okay, step number 2 is what, TJ?
Find standard deviation.
Standard deviation. Do you remember how to do that? Should I make you do it by hand? Probably should, since you guys ran out of time last time. What's the quick and easy way? Equals what? STDEV. Which one do I pick? It's .s, or I like this one. But either one's fine. .s or this one, because it's a sample. Okay. So my sample standard deviation is 2.29 and 7.74. Okay. Step number 3 is what? I'm going to pick on Jessica. Finally remember your name. Okay. What's my next step? Find the products. No, you missed a step. Find the Z-score. So we need the Z-score for the speed, and we need the Z-score for the yards. Can you help me find the Z-score for the speed? You're a little behind. We'll ask a question. The 2 things that you have to put in? Equals STDEV, and then you highlight your data. Just like that. Does that make sense? It's because you're using a Mac. No, just kidding. All right, so Jessica, did you figure it out? Okay, so equals, let's do the parenthesis. And what does X sub I stand for? Stands for your data. So what do I click on? I'm going to click on the 100. Okay, we're going to do this for every single data point. And then what am I going to subtract? Mean, what's my mean? 101.875. Then I'm going to close my parenthesis and I'm going to divide by standard deviation, which is 2.29. Very good. Okay, is that correct? Sort of, okay. Michael, said to press F4, and he is correct. I'm not going to do that because I want to make a mistake on purpose, because you guys got to figure out how to fix this, okay? So that, if I try to copy and paste that down, I get a bunch of division by zeros. Okay, so you got to know how to fix that. But Michael, if you study with Michael, he'll help you figure this out. Okay, he said to press F4. Where do I press F4 on? The last one we need an F4 on, so it's got dollar signs in it, and on the A19, which is the mean. Do I do it on the A10? No, I want that to change. Okay, so I got the same value I did before, but now when I copy it down, it works. Okay. So I'm going to pick on Garrett. Can you help me do the Z-score for the yards? B10. Oh, you okay? I just minus the mean, which is the 266.75. Okay. Lock that with the F4. Okay. Close my parenthesis. Divide by 7.74. And lock that with the F4. Okay. Now I'm going to copy that down. That works. What is the next step? So I remember Adam's name, but who's sitting next to Adam? What's your name in the back row? Merrill. What's the next step? Nope. Find the product. So I need to find the product. What am I finding the product of? The 2 Z-scores. So I pick this number, I'm going to multiply it by that number, right? Do I need to F4 that? No, we want those to change, okay? We are going to do that for all of those. Step number, what's the next step, Gabriel? Find the sum of what? Sum of all those products. So I'm going to hit my auto sum button here. 6.57. The last step is divide by what? Divide by n minus 1. So my question is my n 8 or 16? What do you think, Kaylin? Ah, 8, you're kind of on the right side. So 8 was the right answer. So this n represents your number of pairs. Remember, it's the same person. We're measuring how fast his swing is, 100 miles an hour, and then we're measuring how far the ball is. So it's the same person measured twice. So this is your number of pairs. Okay? What happens if I don't have that number there? Everything changes, but I also have to get rid of that number. Okay? So you got to have a matched pair in this case. Okay, so I'm going to take this number and I'm going to divide by, in this case, if I've got n is 8, I'm going to divide by 7. Okay?
So we divide by 8 because the only divides.
It's n minus 1. N minus 1. So we're dividing by 7.
Yes, I know.
Okay. So we divide by 7.9387. Kendall, is that moderate, strong, or weak? Strong, because it's greater than 0.7. Okay. Would it matter? What if it was a negative? I'm going to make this negative just for fun. What if it was negative? Is it strong, moderate, or weak? It is still strong. Okay. So the sign doesn't really matter, although your thing. Now, what was the first step that I skipped that I was supposed to do? I can't believe I skipped that step. Huh? Look at the scatter plot. How come you guys didn't stop me? Okay? Because I don't even know if this is any good, because I should have done a scatter plot. Yeah, we could have just wasted it all. Okay, so how do we create our scatter plot? Tell me your name. Preston. Scatterplot. Now, by the way, when you do this, make sure that the speed and the yards are selected. That'll make your life a lot easier. Okay. Scatterplot. So it's not labeled very well. How do I label it? Click on the plus sign. Axis titles. What is this over here? Distance in what unit? Yards. Now make sure you put yards on there because otherwise we'll be like, I don't know what that means. And what should this be down here? Speed in miles per hour. Okay. And what should I put up here? Yeah, so this is a golf swing or a golf swing on 70-degree day, something like that. Okay. Now we should have done this step first instead of last, but what do you think? Was our work in vain, or does that look like a straight line pattern to you? It looks good. That looks like a good straight line pattern, so we're probably okay. All right. So, God, we're even done. We're done even earlier than the last class. That was because I started passing out the quizzes that I found out were the wrong quizzes. Yes, question.
So, just tell me why maybe, but should the axis not be at 0?
Okay, so that's a good question. You need to see your data, and I'm glad you asked that question. So his question was, shouldn't the axis be 0? So if I change that to 0, in fact, let's change this one, yeah, and then let's change this to 0. Can't see anything. So you need to be able to see your data. So very good question. But yeah, in this case, I would just leave it alone because I got to be able to see what the pattern's going on. Otherwise, it was just a little ball there. Yes.
Is that because you're interested in seeing if it's a straight line and not like a slope out that way?
That's correct. Yeah, yeah. So, yeah, so we want to see if it's positive or negative. Is this positive or negatively sloped? Positively sloped, which we got in that there as well. Yes.
So like on our test, would you want us to add a trend line so we can see more or less where the
So we're going to talk about trend lines tomorrow. For today's homework, I'm going to say no. For tomorrow's homework, I'm going to say yes. So it depends on what you're trying to do. Now, by the way, just a word on the test that we just took. So remember the one that we did on the marathon times, it was supposed to be a line graph? And some of you did a scatter plot and put a trend line on there. I didn't, that was actually wrong because we're not looking, you're taking year, does year cause the speeds to go up or down? No. Whereas would you say that speed would cause how far your ball goes? Okay, so speed would explain that. So it's the difference between, so remember we were tracking times over a series, that needed to be a line graph. In this case, we're trying to see, is there a relationship between speed and distance? There would be. So this is a scatter plot as opposed to a line graph. Okay, so some of you did put a trend line on there. That was wrong because that's the wrong process for what we were trying to do. But on something like this, we'll talk more about that tomorrow. Okay, but for correlation, not normally you probably wouldn't put a trend line in there yet. You will do that for regression, which we're going to learn about tomorrow. Now, who wants to watch a movie? Okay, this is going to be a fun statistics movie. It's from the movie called Freakonomics. And here we go, cause and effect. Oh, actually, I'm going to stop sharing because I don't want to break any copyright laws. But this is from Freakonomics, the movie. Let me stop recording if I can remember how to do that. Oh, why is this being dumb? Pause recording. Okay. So, Here, I think that's what I want to do. Okay, so let's talk a little bit about this for a minute. So this is ice cream consumption and polio, new cases of polio. And it does look pretty well correlated, doesn't it? Okay, does ice cream cause polio? No. Okay, so you've heard the well-worn phrase, correlation does not imply causality. Okay, but that doesn't mean there's not a relationship going on. So correlation doesn't imply causality. So this is a really interesting graph for a couple of reasons. Number one, is it a linear graph? No. But you could probably, maybe from here to here, you could probably split that in half and say, well, it's linear from there to there, and then it's linear from here to here, right? So you could kind of use that. So the fact of the matter is, even though correlation doesn't imply causality, you could use the percent of ice cream, I don't know what the units are, the ice cream sold and predict the number of polio cases. And you would be pretty accurate, okay? So correlation can be useful even when it's, in this case, ice cream isn't the cause of polio. Now, what caused polio? Anybody know? It's a virus. How do you get the virus? What's that?
Coming in contact with the virus.
How do you come in contact with the virus? Anybody know? What do people like to do in the summertime? Swim. That's how you come in contact with. You swim in infected lakes and pools. Okay. You also happen to eat a lot of ice cream in the summer, right? So we've got a lurking variable on here, which is not. So the lurking variable is not ice cream. It is swimming, and there's a pool in a pool. Okay. So these are related, kind of in a strange way, and that's why we can actually use it for prediction, even though ice cream doesn't cause polio. So we'll continue with this tomorrow. Is there anything else I want to talk about? All right, I think that's it. So we'll save this for tomorrow. Your quiz will be on 3, 5, and 4.1 tomorrow, since we'll just make up since today is messed up. Okay, so see y'all tomorrow. I figured it out.